Hey guys, welcome to Unit 3, Section 3. So if you were in class, you probably have seen this. So you can skip until the part in the video where I get to this. So if you've already seen these other two slides, but for those of you that haven't, congruent figures are figures that have congruent corresponding sides and angles. So when we're talking specifically about something like a triangle has three sides and three angles. So if we are comparing two triangles, that means there's three sets of sides that are congruent and three sets of angles between the two triangles. So if we look here at our first triangle is GEI. So for comparing sides, that would be GE is congruent with MQ. The way we know that is because of the double tick marks. We know that those are corresponding sides, and they are congruent because the tick marks indicate that. So that's one set that's congruent. Now we're going to go to EI. That is congruent with QO, because that has triple tick marks for both. And then lastly, we have GI is congruent. I should put my lines over top. GI is congruent with MO. The single tick marks go together. Okay. Now we're talking about angles. So angles, we only need one letter to name these angles. We have to be careful with that. So angle G is congruent. Angle G is right here. That has two arcs. I'm going to erase these here. So angle G, we have two arcs, so we want to find M that also has two arcs. That is congruent. And then we have E, which is congruent with Q. And then we have angle I, which is congruent with O. Okay, now that we've shown and demonstrated that we have three pairs of congruent sides and three pairs of congruent angles, everything about these two triangles is the same. Therefore, we can conclude that they are congruent triangles. But we need to write that in a congruent statement. So how that looks is, I'm going to write it up here. Triangle GEI is congruent to triangle MQO. Now it's important that we do use the proper order for when we're naming the triangles. So GEI is the order that I want because M corresponds to G, Q corresponds to E, and O corresponds to I. So I have to make sure that those match up with each other. All right. Now we're going to look at these two here. Are the triangles congruent? Oop, I got to get rid of that. Okay. I had something on here I didn't want, but that's fine. All right. So if we're looking at these two triangles, notice that we have a shared side between those. So I didn't mean to have this part here, but it's fine. Since they share a side, that side is actually congruent to itself. So how we write that is NL is congruent to NL. And if you recall, whenever something is congruent to itself, that's possible because of the reflexive property, which we've already talked about. So now we have 1, 2, 3 sides, and then we have 1 tick mark, 2 tick mark, 3 tick mark. So the sides are congruent, and then we also have 3 sets of angles. So we have NLK as well as LNM. I know it doesn't really help when I put all these little dots here. But the idea is there are 3 congruent angles and 3 congruent sides that we can find for each triangle. So we can actually conclude that triangle NKL is congruent with triangle LMN. Now notice, when I did N, I was looking at the single arc, and then I went to K, which has the triple arc, and lastly to L. So when I do to the other triangle, I have to start with L, because that's the single arc, just like this N was. So then I went L, M, N, because order does matter when we're talking about the congruence statement. All right, this one over here, are the triangles congruent? How do we know? Well, we have 1, 2, 3 sides, 1, 2, 3, so we can conclude that we have 3 pairs of congruent sides. But the angles, we only know 2 here. Notice the third angle for each triangle would be here and here. But how can we conclude that those are the same? Well, if you recognize that they're across from each other, they are vertical angles. So what we would say is angle DEG, which is this angle right here, is congruent to angle HEF, which is this angle right here. Now those are congruent because of vertical angles. Okay, and then we can also now say, because we know that we have 3 congruent sides and 3 congruent angles, that triangle DEG is congruent with triangle HEF. All right. Now, it's a lot of work to kind of go through and ask yourself every single time, do I have 3 pairs of congruent sides and 3 pairs of congruent angles between the 2 triangles? It's actually easier if we use some shortcuts. So we do have a few shortcuts that work. Now, this is the first time that you guys are seeing these. There are 5 shortcuts that work. Typically, I'd like to do investigations and talk through each one of these, but we just don't have enough time to do that, so sadly, won't be able to. If you've been in class, though, we did talk about this one here. This was the spaghetti example. So side, side, side is, if you know 3 sides are congruent between the 2 triangles, we can conclude that all the angles are also going to be the same, and therefore the triangles are going to be congruent. So this is a shortcut rather than finding all sides and angles. Another one is the side angle side shortcut, where you have an angle in between 2 sides for both triangles. The third one is the angle side congruence one, where you have 2 angles and then a side that is not in between them. It has to be on either side of the angles. We have the angle side angle shortcut, which is 2 angles and then a side in between the 2. And lastly, we have this special one that's only for right triangles. It's called the hypotenuse leg shortcut. Hypotenuse is the longest side of a right triangle. It's always across from the right angle. And then the leg is just any of the other sides, but it has to be matching for both triangles. And then there are 2 shortcuts that do not work. And I'll explain why these 2 don't work in class. So make sure that we are not using either of these, the SSA or the AAA. Those ones do not work. These are the 5 shortcuts we want to use. All right, now let's do a little practice with these so you can see how do we identify which situation we have. So it says determine whether each pair below shows a congruent triangles. If so, what's the reason? If not, why not? If the triangles are congruent, write a congruent statement. So these first 2 here, notice that we have, here is 1 tick mark, 1 tick mark, 2 tick marks, 2 tick marks. So we have 2 sides that are congruent between the 2 triangles. And then we also have an angle in between the 2 sides. So if you look back up at this handy little chart, you might want to look at this while you're doing some of the problems in the follow-up worksheet. So 2 sides, so it has to be one of these that has 2 S's in the name. And then the angle is in between. So this is going to be this situation right here. Side, angle, side, because the angle is in between the 2 sides. All right, so for this one, we can conclude that they are congruent, so we have to write a congruent statement, which would be triangle MNL is congruent to triangle OPN, and then we would say by the side, angle, side. You don't even have to say or write it out. We can just use the acronym for that. All right, let's go on to the next one here. So we have 1 tick mark, 2, 2, 3, and 3. So these are all referring to sides, even though we don't know anything about the angles. Since we have that shortcut, this is the spaghetti one, we know that if you have 3 pairs of congruent corresponding sides, the SSS, we know that this is a shortcut that can prove the triangles are congruent. Now the tricky thing is we have to make sure that we organize the letters correctly when we make our congruence statement. So notice that if I start with A is between the 1 and 2 tick marks. So we got to find the letter that's in between the 1 and 2. So 1 and 2 is B. So triangle A, I'm going to leave some space. Triangle, and then I know B starts the other one. Actually, let me give myself a little more space here. A. And if you want, you can just do an arc like this to remind yourself. So there's B. Now I'm looking for C. So C is in between the 1 and 3. So the 1 and 3 is F. So notice they're not in the exact order we might have predicted. C, then F, and then finally D and E are the last ones we didn't mark. So ACD is congruent to BFE. It is important that we get the right angles to correspond, okay? And this is by side, side, side. All right, we got a few more to practice here. Here we have A, B, C, and D, E, F. Notice this time we're given two angles. So this is a pair of congruent angles. This is a pair of congruent angles. And then we have a side in between. So let's go back and check and make sure that's one of our shortcuts. So if you look over here, this is the angle, side, angle. The side is in between the two given angles. So triangle BAC is congruent to triangle EDF by the angle, side, angle shortcut. We're going to need to know these shortcuts by heart because eventually, well, we are going to take a test on these and they're going to be important once we start proofs. Okay, so with this one, let's go ahead and look here. Notice we have two given sides. So one tick mark, 2, 2. And then we have a given angle right here is congruent to this angle. So just because we have three pieces doesn't guarantee that the triangles are congruent. They might look exactly the same, but remember, we don't go based off of looks. We want to go based off of what we know. So is the angle in between the two sides? That's the real question. Since this is technically the angle that's in between our two given sides, and we don't know anything about those angles, this is one of those situations where we actually have side-side angle because we have the two sides here, but the angle is outside of them. It's not in between. So this is actually not one of the shortcuts. So this is no because of side-side angle. They might be congruent. Just because it's a side-side angle situation doesn't mean they aren't congruent, but we can't prove that they're congruent because of that. All right, and then we have this one here, and this is where we have two given angles, here and here, and then a side. Now notice the side is not in between these two, but it doesn't actually matter for this one. We have a shortcut where it's angle, angle, side, where it's two given angles, and then the side is not in between them. So this one does work. Make sure though that we gotta name this properly. So this is triangle TSU. It's congruent with triangle KJL by the angle, angle, side congruence. All right, there you go. Go ahead and try the practice problems.